Hi, I'm Dr. Scarlett Rain. In this talk, I will motivate AI as an emerging trend for underwater perception, ecosystem monitoring, and marine robotics. Marine ecosystems are among the most biodiverse on the planet, yet they are under threat from climate change. We urgently need scalable technologies to monitor ecosystem health and support active restoration. Underwater perception is gaining traction and has seen a huge uptick in research interest. We identify three core drivers for underwater AI as an emerging trend. First, there's a pressing need to find new solutions to climate-driven ecosystem loss. With estimates that we could lose up to 90% of the world's coral reefs by 2050, this is a significant motivator for developing monitoring and restoration technologies which support marine conservation. Second, the availability of labelled underwater imagery has been historically limited due to the need for expert annotations. A shift towards citizen science initiatives, the emergence of corporate social responsibility programs, and the use of gamification is driving greater availability of large datasets. Third, as traditional AI fields become saturated, researchers turn to the underwater domain, which brings unique challenges, meaning researchers can make more transformative contributions. I will now overview the core trends in underwater AI in context with the challenges driving this innovation. This figure highlights the significant increase in underwater image datasets, which drives innovation in foundation models and generalizable scene understanding approaches. Scene understanding has been limited by the cost and time for experts to label imagery. Historic datasets use sparse point labels. These sparse annotations have driven innovation in weakly supervised segmentation, where the points are propagated into pseudo-labels for training segmentation models. While Dino v2 is ineffective out of the box on coral images, we have shown that novel human-in-the-loop approaches can be combined with Dino to minimize human annotation effort. This demonstrates that the unique challenges of coral data are driving innovations in weakly and self-supervised learning that can be applied beyond the marine domain. Large image datasets are fueling the development of general underwater scene understanding approaches. Coralscapes is the first general-purpose dense semantic segmentation model. Our recent work studies the impact of camouflaging species for underwater object detection and identifies that, even when balancing the training set, visual characteristics and behaviors of marine species impact the performance of object detectors. Scene reconstruction for underwater environments has undergone dramatic shifts with underwater-specific 3D Gaussian splatting methods that account for underwater optics and are significantly faster than photogrammetry workflows. The emerging trend of AI for underwater environments has already begun to deliver tangible benefits in many industries. For example, in reef restoration, robotics and AI enable order of magnitudes increases in operation scale. Here, you can see a robot with an associated AI system automatically tracking coral growth and survival rates. AI gives marine scientists the tools to address urgent environmental challenges. At the same time, the complexity of the underwater domain, its turbidity, unstructured settings, and fine-grained biological variation pushes AI researchers to innovate.